Hi guys, if you have questions, email me or write a comment.
Hi, let's talk about this interesting topic, trigonometric functions or trigonometric ratios. Let's try to make this topic easy as it should be. I'm gonna start with the differences between geometry and trigonometry. Why am I gonna do this? Because in trigonometry we're gonna talk about angles and triangles. So let's remember angles in geometry. As we all know, you can draw an angle this way. For example, let's say this is 30 degrees. You can draw it this way and it will still be 30 degrees. This way, 30 degrees. Actually, this will be the first difference between geometry and trigonometry. In trigonometry, you cannot just draw angles the way we want. It should be drawn in something called the standard position. And what is standard position? It's when you start from the origin, 0, 0, and the initial side, which will be always the positive x-axis, so this will be the initial side, and then you move until you reach 30 degrees, and when you stop, this will be called the terminal side. So in geometry we can draw in any position. In trigonometry we have to start with the initial side and end with the terminal side, and our movement should start from the positive x-axis in this direction counterclockwise. That will be important. Okay, that's the first difference. The second difference actually is that the measure of the angle, the measure of any angle, let's say theta in general, the measure of any angle is between 0 degrees till 180 degrees. We know that we have acute angles between 0 to 90. We have right angle, which is a 90 degree exactly. We have obtuse angles between 90 to 180, and we have the straight angle, which is exactly 180. What about trigonometry? In trigonometry, actually, the measure of any angle could be any real number. So it could be positive, it could be negative, it could be rational, fraction, decimal, it could be anything. And how would that affect our drawings? Actually, if you try, since it could be anything, so we can try to draw some angles in trigonometry. As I started, we did start with 30 degrees, so I'm gonna put 30 as our example here. Let's try to say 30 counterclockwise. You can draw, for example, 150. So again, you start from the initial side, move counterclockwise until you reach 150 degrees. Remember, we have initial and terminal side. Okay, I can draw more than 150, which is one of the differences that we said, more than 180. So again, you start from initial, move counterclockwise until you reach here. For example, let's say this is 210 degrees. So now we moved more than 180. We can still move more. We can draw, let's say, 330, for example, 180, 270, let's say somewhere here. So this is 330 degrees. Not only that, we can still draw negative angles. But how would that happen if I want to draw a negative angle? Actually, same thing, but when you move clockwise, so you start again from the initial, but move clockwise 30 degrees, that will be called negative 30 degrees when you move clockwise. Same thing If you want to draw more than negative 30, let's say negative 150. So again, I'm gonna move from the initial side clockwise to 150, and that will be negative 150 degrees. Well, these are the main differences: the position of the angle and the measure of the angle. But there's something interesting that I want you to notice here, because that's an important thing to know. Look at me when I did these drawings. This was 30 degrees. Now, if we look at this angle here, the 150, how much is left between 150 and the x-axis? We all know that a straight angle is 180, so up till here it's 180. So what was the distance between 180 and 150? It was 30 degrees. This angle is important to know for the future, and this will be something basic. We are going to call it the reference angle. Look at this angle, 210. Until here, you have reached 180 again. So what comes after 180 until you reach 210? Actually, it's again 30 degrees. What about here? It's again 30 degrees until you reach to 360 degrees, a full circle. Here, actually the reference is still 30 degrees. What about here between negative 150 and the x-axis? What's left is 30 degrees. We are going to call these angles reference angle. So for each angle in trigonometry, we have a reference angle which will be defined as a positive acute angle between terminal side and that's the important part, and the x-axis or the horizontal axis. Let's have another look at these. Look at this. Here is my angle, and the reference was between the terminal and the x-axis. Here I have this as a terminal, and the reference is between the terminal and the x-axis. Same thing here, between the terminal and the x-axis, between the terminal and the x-axis. So it's 30 degrees for all of the angles that I did. So 150, 30, 210, 330, negative 30, negative 150, all of these have the same reference angle, which is 30 degrees. Okay, and since we said angles in trigonometry can have more than one measure, so it might happen that we have two angles with the same terminal side. Let's say I want to draw 30 here again. I like 30. Let's say I'm going to draw 30 here again. What will happen if I want to draw 390, since we said that the measure of the angle in trigonometry could be any real number, and it could be positive or negative. So let's say I want to draw 390. How am I going to do that? I'm going to move a full circle. So that's 360. Then I will go up until I reach 30 again. So this is 390, which has the same terminal side. These angles actually are called coterminal angles. So when two angles have the same terminal side, we call them coterminal. Well, is it only one angle that will give me a coterminal? Let's have a look. Another angle. Let's draw the 30 again and see, can we have another coterminal with 30. Okay. Let's go a full circle, 360. Another full circle, that's 720. Until I reach the 30, that's 750 degrees. So till now I have 30, 390, 750, and actually I can keep going with circles, and that will give me the same terminal side. So I will have infinitely many coterminal positive angles. Now how am I going to get that? Simply, it's 30 plus 360s. But how many 360? Well, I don't know, so I'm going to say plus 360 times n, where n is any integer. So 1 360, 2 360s, 3 360s, and so on. Okay, what about the negative? Is it possible to get negative coterminals? Of course, it should be the same thing. Let's do an example with positive coterminals, negative coterminals, sorry. So let's say this is positive 30. The first negative coterminal is easy to find. We have to go clockwise, we have to go clockwise until we reach here. The full circle is 360. We're going to take 30 out, so this is negative 330 degrees. And of course, I can keep going with more than one full circle. So how am I going to get negative coterminals? Simply 30, instead of plus, it will be minus 360 times n. So we have, so far, we know that we have differences. Angle in trigonometry should be in standard position, initial and terminal. Measure of the angle could be any real number. And we have something called the reference angle. And also, we have coterminal angles. Okay, what's the other thing that we should know about angles? Actually, it's the measure of the angle. We are all used to degrees, but actually there is another way to measure angles. Let's say we have this circle here, and there is an angle drawn inside. For example, I'm going to talk about this angle in general. Let's say theta. Well, what's the other definition for the measure of the angle? Actually, the other definition for the measure of the angle is said to be the amount of rotation until the terminal side. How much did I move here? And that will be the ratio between the arc and the radius. Okay, how am I going to do this simply? I will make it this way to make it easy for you. What's the circumference of a circle? It's 2 pi times r, the radius. That's good. What if the radius was 1? So the circumference would be equal to 2 pi. Well, according to the definition of the new measurement, it says the amount of rotation. So if I'm talking about the full circle, then the amount of rotation was 2 pi, which means actually the 360 degrees is the same as 2 pi rotation. This would be the measure of angle in degree, and this would be the measure of angle in radian. So since 360 is 2 pi, this means that 180 will be what? 2 pi divided by 2, which is pi, and so on. If I want 90, that will be pi over 2. Well, what does this mean? Does that change the value of pi? Actually, no. Pi will always be 3.14. It will never be changed. We know that it's an irrational number. This means that 90 or 180 is equivalent to pi radians. And if we try to find 1 radian by divided by pi, this means that 1 radian, if you divide 180 by pi, this would be approximately 57 degrees. It's 57 point something, so approximately it's 57 degrees. So 1 radian is equal to 180 over pi, which means to convert, and that's important, to convert from radian to degree, we need to multiply by 180 over pi. And to do the opposite, to convert from degree to radian, we have to multiply by pi over 180. Let me give you an example about this. Let's say we have 60 degrees. How am I going to write this in radian? Simply, I will say 60 times pi over 180, since I'm converting from degree to radian. After you simplify here, over 60 that's 1, over 60 that's 3, so 60 is equivalent to pi over 3. And does that make sense? Yes, we have just got here that pi is equivalent to 180, which means that 180 over 3 will give you 60. Another example. Let's say I want to convert 210 degrees into radian. How much would that be? Again, from degree to radian, we multiply by pi over 180. So when you simplify here, over 10, the 0 will go. So 21 and 18, that's over 3, 7. Over 3, that's 6. So actually we'll get 7 pi over 6. Okay, what about the opposite? Let's do from radian to degree. Let's say I have 2 pi over 3. How am I going to convert this? This means 2 pi over 3, which is radian, should be multiplied by, so from radian to degree, you multiply by 180 over pi, so this would be times 180 divided by pi, and the same thing when you simplify, pi with pi will be cancelled, that's the first thing. So over 3, this is 1, over 3, this is 60. 60 times 2, that's 120 degrees. That's for measuring. I will explain later about trigonometric ratios, from where did we get that, and how to deal with it.
Remember to like, share, and subscribe, and write your questions via email or comments.